Oh, my goodness. Thank you all so much for coming. I'm so excited. I'm going to try to talk slowly because I often get very excited, and then I speed up. And so let's all be zen in our location learnings today. So who on earth am I? Oh my gosh. So this is my first PyCon. This is the first time I've ever spoken at a PyCon. 1 year ago, I had never even written a line of Python code. I am an engineer. I'd done a lot of Java, C++ work, but I started doing Python and I loved it, and I've met amazing people in this community. And so here I am today. And a lot of this work goes over stuff that I did in the fall of 2012. The only reason I say that is that things move fast in technology, and some of the things that I say, almost all of them are relevant now, but some of the reasons that I'm going to give will make more sense if you think back to October 2012. So I want to go over at a high level what you're going to get out of this, in case any of you are like, what am I doing here? I want to go back and eat more food in the sponsor booth. So the thought here is there's a lot of sites on the internet, Yelp, I use the example, where you've got this Omnibox, where you can type in a zip code or a state or a location, and out of that box, you will get a list of, in Yelp's case, restaurants. So how would you even build a box like that? How do you capture user input, any sort of user input about any geography? How do you store it, and how do you sort it? And so if you too want to build a Yelp clone and start your company and then IPO to riches, you're in the right place. This is the stack that I was using at the time. So this talk is going to be pretty Postgres heavy and pretty Django heavy, but if you do not use either of those technologies, do not fret. At the conclusion of the Postgres part, you might be a MySQL, you might roll in with the MySQL folk. Like, that's totally cool. Some of these concepts will apply. It will be Django heavy, but you can probably abstract this into other frameworks as well. And then in the bonus round, there'll be some really crazy stuff. So you better hold your seats. So why on earth would someone want to build an Omnibox, that I like to call it, like Yelp? So I was at a startup in the fall where we took a very cheap and easy approach to handling location data. And the cheap and easy approach is we use lists of strings. So I have an example here. I've been told that it's a little hard to read, but don't you worry, the slides will be on the internet and then everyone will be able to see them. But we basically had a list of location strings, and we would display that in a dropdown. So a user would come to our site, and he or she would want to find all of the wedding vendors nearby. And so he or she would choose San Francisco from the list, and all of the San Francisco vendors would show up. And we would do this by string matching, by saying, like, this person is looking for San Francisco, that is equal to the string San Francisco, we would show all the vendors. Now, this got us pretty far, but after moving to a spatial database, what we really wanted is a user to come to our site, type in this box, type anything in the box, and they would get all of the wedding vendors within a specified radius of them. Now, the string solution wasn't all that bad. It was super easy to implement. It was great for a minimum viable product. It did not require a lot of infrastructure. It did not require a lot of logic. So when you're thinking about moving to geocoding and handling geospatial data, just remember that strings might get you most of the way there. But the problem that we had is that for user-facing search, this became increasingly non-ideal, meaning that if I'm in Sacramento and I want to find all of the wedding vendors in the greater Sacramento area, that might include places like Lake Tahoe. And so Lake Tahoe and Sacramento, can you guys still hear me? Am I doing cool? Okay. So Lake Tahoe and Sacramento are not alphabetically that close to each other, but geographically they are close. And so we wanted our users to input Sacramento and get all of the wedding vendors in that area without having to maintain lists of data structures saying Sacramento is next to Lake Tahoe. We should be able to do this with geographic data. So, and just to note, if you think that, oh my gosh, this talk is going to be way over my head, it probably, I've really tried to make that not so, because when I wanted to approach this problem, when we wanted to build this box where anyone could type anything in, I'd never done anything like this before. I mean, it's very classic startup, right? You're like, we want our startup to do this. How are we going to do it? Who knows? So let's find out, and let's build it. So So now that I've convinced you that you might want to go down this spatial route after you think about your string solution, this is how the rest of the talk is going to go. We're going to go over the database, how you need, what kind of database you'll need to store it, how do you build that database. We're going to go over application layer, which is going to be the Django, GeoDjango layer. We're going to talk about front-end JavaScript geoencoding, and then the bonus round starts. So, in terms of a database, you don't have to go with a spatial database. If you want, you can do mathematics. Some of you probably enjoy mathematics. Here's the formula that you would need if you wanted to compute distance between 2 points on a sphere. It's called the Haversine formula. We thought about doing this, but I'm not really someone who likes to write a lot of Mathematica code, or nor did I want to write this in Python. So we decided on not going that route. So the next route that we had considered, and these are things that you might want to think about as you're going to a spatial model, is do I just want to use a spatial database? Maybe I'm using pylons, maybe I'm using a different framework, Flask, and I just want spatial data. Well, you can do that too, but then you're going to be writing a lot of SQL. And that's something that we also considered. Like maybe I just go to PostGIS and I use Django and I write a lot of queries like this. Queries you probably can't see because of low contrast, I apologize, but don't worry, you don't need to worry about them anyway. Because at the end of the day, we went with number 3, and that is we're going to use a spatial database, PostGIS on top of Postgres, and we're going to use GeoDjango as our abstraction layer for communicating with the location data. Now that we're all on board and the train is moving forward, we need to install Postgres 9.2. So I'm not going to go very deep into a lot of these slides. The purpose of me putting a lot of this up here is because I found very disparate and often conflicting information about how to run PostGIS and Postgres on Ubuntu, which was the stack that I was on. So you need to install this. Here are some commands. If after the talk you go through these commands, I feel with high confidence you'll be able to do this. But me walking you through a bunch of sudo commands, probably not the most exciting talk. So let's say you have Postgres 9.2 up and running. And in the fall of 2012, Postgres 9.2 is kind of the bleeding edge. So we installed that I built it from source, and now you need some spatial libraries. Now, I made the classic new mistake where I'm like, oh, I need some libraries. I'll just install them in whatever order I want, and then like all will be good in the world. And that's not fundamentally how this works. So you need to install these libraries in a prescribed order. And so I would go GIS, GL, PostGIS. And so as long as you ensure that you're installing in the correct order and you're not installing versions that conflict with each other, you're going to be cool. Now, I would highly suggest you take a look at the link on the bottom of the page. I actually pasted in a bunch of diagrams, and it was like such a horrible eye test that I had to remove it, because there's a lot of certain versions won't work with other versions, and it's like this kind of fun game. But hey, I figured it out through these tables. You'll be able to figure it out. So finally, you're going to install and build all of these libraries, Geos, PostGIS, and then after you get there, after you've got all of your libraries installed, you're going to go ahead and load the spatial libraries into Postgres. And I also want to mention this works if you have an existing Postgres instance where you want to now use location data. And that was my case. We had a production system, thousands of users every day. We had a pretty large Postgres instance, and I was converting it. But this can also work if you're spinning up a new application and you just want to mess around and play with data. So you load your spatial libraries into your existing database, or you create a database and load those libraries. Here's another fun eye test for you. So when I was doing this, and I realized that a lot of people hadn't gone through Postgres 9.2 and PostGIS 2.0, I created a stack script, which is a shell script of how to install all of this. I was on line node, so this is a script that will work if you want to spin up a line node instance, but this is also a great script if you're running on AWS or some sort of infrastructure, and you want to go through and copy and paste lines of like, here's how you get all these libraries, here's how you install. So the only purpose of me pasting this in here was because it was mildly colorful and an interesting graphic, and I didn't want people to fall asleep on this slide. So now here's, I think, where things get, I promise, if you're now like kind of bored by the database stuff, we're slowly, we're climbing out of the database hole up through the stack. So like after you do all this, there's this question like, how did it work? You've installed all these libraries and you run all these commands and you're like, what's supposed to happen now? And I found that there's a command right here, and I apologize that it is hard to see, but you can read off the slides later, but you can run this command, and it shouldn't barf when you run it. It should give you versions that are correct, and then you know that all is well in your GIS world. Now we're going to go up, we're almost out of the database layer. So at the time, PostGIS 2.0 didn't play well with Django. And this is one of those sad times when I was running Django 1.4.3. This was, remember, in October. Things may have changed. And I ran these database commands, and I'm like, awesome, my database works, celebration. And then I was getting a lot of Django errors, and that's because the database adapter for Postgres in Django 1.3 does not work well with PostGIS 2.0. So at this point, what you do in a lot of these situations is you think should I fork Django? And in that case, you're always no, don't do that. That's not a route you want to go down. So what I had to do, which I'm not going to go heavily in depth because it's not that awesome, but I had to copy the adapters locally, make some modifications. The directions are right here on the slide. If you follow these links, I promise you will be totally cool. So the final step in hooking it up with Django, so I can't use the PostGIS database adapter because it doesn't work, so I had to modify it and copy it locally into lib PostGIS. So I point in my settings file in Django, I point to lib PostGIS, and then if you're using South for database migrations, if you don't tell South what's behind the scenes, South starts to get really upset. So I also have this command here to tell South that, hey, back here is a Postgres database. Okay. All right, database out. Anybody who is not interested in the Django layer, y'all can go to sleep for a couple minutes. I'll wake you up soon. Okay, so now we're going to do a fun geography interlude. So I hadn't really thought about geography in many years before doing this, and it's very important to remember, although it is obvious as you think about it. The Earth is a sphere. It is not a plane. And so, but a lot of the documentation when you're going through these libraries assumes that if you want to treat the Earth as a plane, and I'm always what, no. But for very short distances, mathematics between 2 points on a plane is very simple, right? Computers can't multiply and divide. They can they can add, they can subtract, and when you want to compute the formulas, the distance formulas for things like spheres, then that math is more complex. And so in going into this, you need to know that this is not, oh, it didn't show up. There we go. That when you're computing on an Earth, it's not as simple as doing 2 points. So this is abstracted away from you, but when we hook Django up to, when we want Django to know about geospatial data, there are parameters that you will want to either use a sphere or a plane for. So in this example, and I apologize, it's a little hard to see, but don't worry, it's cool. In your model, you need to add a point field and a geo manager. So this is for my Yelp example. There are tons of other things you can do, but in this case, you need a point field because you're going to be storing a lat-long object. And when your geography equals true, that means that all calculations on those point fields will be done with the Earth being a sphere and not a plane, which seems more ideal and more accurate, at least I think so. So I took our existing object and I added those two attributes. We already had this data, I just stuck them in there. And now, here's how you would create a point field in the Django ORM. So you have a latitude and longitude. We'll talk about how to get that from your user later. You get a lat long, you can encode it, you can save it. This slide is primarily for reference for you later. Now, what is geocoding? So before we exit out of the Django steps, the Django application layer, and we go into the front end, the JavaScript layer. So geocoding is the process of taking a string, a zip code, Santa Clara, California, USA, Macedonia, and getting a lat long out of that. There are many public libraries that do this for you. I use the Google Geocoding API in order to get lat longs that were entered from user-generated input, and also to convert all of my legacy strings to latitude and longitude. So you've got string data, you want the gold standard of lat long data. Now, let's go through a really quick example of this. So if you bring up Chrome right now and you type that URL into your browser, you do not need an API key or anything like that. You are talking to the Google Geocoding API. Then boom, you're going to get all of this JSON back, and it's going to come back really fast. And this is all JSON around, like, here are all the metadata about this geographic location. Here's like bounding boxes. Here's all this, and here is a latitude and longitude. And this small box of all of this JSON is what we care about because we want to pull that lat long out. I've also included a couple pointers. If you're going to be doing a lot of JSON in your browser, you want to install an add-on to make it human readable, because if you don't, like, it's just going to make your life less awesome. So, go in here now. So, I had a bunch of strings like San Francisco, California, and I needed to get them geocoded because I was moving our application to only use latitude and longitudes. So here is a simple script that I wrote. I would not advise you to run this script in production, but I needed to go through and I needed to get all of these lat longs. So it's just like a simple, quick and dirty Python script. You can copy it off the slides later. But quick interlude. So when I was going through and I was calling the Google Geocoding API very rapidly, two very interesting things happened. The first thing is, as I'm storing all these point values, I go into my Postgres database and I start querying for them because I'm like, cool, I got a lat long, I parsed the JSON properly, like, life is awesome. And I get back this like long hex string, and the coloring is kind of funky, but I'm like, I was like, I don't even know what that is. Like, I don't even know how to deal with that. I gave my database, my PostGIS database, the string, like, what's going on, like, and then I made some bad decisions, which I will spare you all of the bad decisions. And then I realized that you need to use a special function if you want to get out your lat long from your database. So if you want to interact with that data on the SQL layer, you need to use a function. And the function is a little hard to see, but I've got it in here. And there are many other functions, none of which I have ever needed to use. But here's a link in case you want to use them. But that is the most important function. Now, so at this point in time, like, we've got this awesome rockin' spatial database, like, life is good, we've converted all our legacy data, or if you have legacy data, you don't have that problem, and you're ready to go, and now you've got these objects that Django knows, GeoDjango knows are location objects, and you can do location queries. And location queries mean you can say, show me all of wedding vendors, restaurants, whatever your data is, show me all of the data within a 25-mile radius. So here are some queries, like less than equal queries, greater than equal queries. So if you do use Django, then you know about when you're using the ORM for querying, you can do less than equal, greater than equal. So it's the same thing for distance. Let's see, so I made when I was like having the grand thoughts of doing all this work, I was like, I'm going to just pick an arbitrary number, 25 miles. And I'm going to show all of the users, all of our wedding vendors within 25 miles. And then you implement this, and you run it against real data, and you're like, holy crap, there's not many vendors within 25 miles. And then, so then you make it 50 miles. And then you're like, oh, what am I doing? And so what I would suggest that you do is that you use order by distance. So think about it. If you're querying for all of your objects in your database, just sort them all by the distance from whatever lat long point you want. And that way you always have input. And you can cut off, like, oh, you can make the list, like, give me 5 of these things. And so this is what I ended up doing, was like, I just show everything sorted by distance, and then I cut it off at a certain point. And that way I don't have to worry about choosing arbitrary numbers for, like, within 5 miles or within 25 miles. Cool. So now we're exiting the Django fun, and now we're going into the JavaScript world. So like I said before, we've got this Google Geocoding API. It's pretty sweet. Now, if you're going to have a box that users are going to type Santa Clara, California, or 94040, or Macedonia into, you're going to need to geocode that input because you need a lat long if you're going to do your queries of your backend to figure out what vendors are nearby. So there's two options when you're doing this. So the first option is you do this client-side in JavaScript. This is PyCon, so write JavaScript is in red because we don't do that here, but unless we have to. And then, but one of the problems is, so the Google Geocoding API will rate limit you by IP address. So the beautiful thing about geocoding client-side is that if you have one user who is using your service to geocode like 250,000 strings, like that's a good problem because you've got a power user. So, but for everybody else, you know, we did some geocoding client server side, and we were getting rate limited because our instance IP, Google knew that our IP was hitting their service so much that I would suggest that you do it client side, because server side, like, yes, it's Python and it's like beautiful and I love it, but you will probably get rate limited. So yet another internet. So this is my next startup idea. I'm gonna start selling these shirts, and you can pre-order them. This is a joke, but so I mean, in doing the development for this, like I got rate limited several times, and it was always when I would leave for lunch. I'd like let it run, and I'd leave for lunch, and then I'd come back and I was rate limited. So. So the way that I geocoded client side was I created a really simple form, a Django form with one field that was shown, which is like user entered address, and then 4 hidden fields for lat, long, and full address, and those I'm going to pull from Google. And so I have this really simple form, really simple HTML template, which allows the user to enter one field. And so here is everything in the orange box is going to come from the Google Geocoding API. And these are all hidden because I'm going to, like I said, pull it. And now here's where things get like a little bit hairy, but don't you worry, like all of this code will be online. So when the user submits the form and types their location in, I prevent the form from submitting. I call the Google Geocoding API, remember we're client side. I then parse the results back, and then I send it back to my Django view. So here is where I am appending to the form all of the fields that I want, which are lat, long, and full address, because full address I just wanted for posterity. And cool. And then in the view, I take that data. I mean, this is a very standard Django view where I take the clean data off the form and I save it to the database, and all is well in the world. I know it's a lot of code, but you can go, it is readily available for you later. So here is the final interlude. So I'm now at a company called Tindy, and Tindy is an e-commerce marketplace for hardware hackers. And what on earth does that mean? So we've got a lot of people who sell hardware, modified Arduinos, modified Raspberry Pis, a lot of robots, and we have a lot of international sellers, and we've got a lot of international buyers. And so one of the challenges that we had was, how do we have a lot of our sellers have a lot of shipping rates. So how do we intelligently show a shipping rate to someone browsing on an e-commerce site? And this is our fun, like, exciting, like, we have all these robots, and robots are shipped all over the world. So this is kind of cool. So here's another service to throw out there if you're bored, and you want to find out the country from an IP address. So we've used this in production. It's pretty awesome, where for anyone that comes to our site, we wrote a middleware, and I'll show you that code in a second, that says, all right, user, what is your IP, queries, gets the country back, and then we show shipping information for a product based on the country of the potential buyer in the client. So here's some middleware that you can plug in if you're interested in. So middleware in Django is a layer where all requests and responses go through the middleware. So the first request that HTTP request that we see from the user, we say, have we looked up this country? And if we have not, we call the API, we set the country, and if we have, then we let the HTTP request proceed as usual. All right. Oh my gosh. So we've now reached the end. I just want to thank a few people who were really instrumental. Like, all great software is not written alone in a closet. It's written with other amazing people like these folks. And I also want to thank PyLadies for all their help. And we are now at the end. We now have our Yelp business. So.
We have a microphone set up over here. We have about 5 minutes left for questions. If you have any questions, please step over here.
Just want to make a few comments. You don't need to do any crazy hacks for PostGIS 2.0 support anymore. It's built into Django 1.5, so no custom backends or any of that. Just use Django 1.5.
I'll delete those slides.
And as far as I know, you don't necessarily have to compile everything from source. If you don't need 9.2 Ubuntu packages on Precise, should work fine.
Cool.
I'll talk to you about your problems later.
Thank you.
Thanks.
It's even better. Your route to millions is even shorter.
My question is about the last middleware that you had. I know that you can get some of this information from, say, MaxMind and do this yourself with the GeoIP library. Is there a reason that you didn't choose to do that? Were the results not accurate, or the licensing wasn't appropriate for your usage?
So this was a very, let's just build something cheap and dirty and see if it works, and not worry about things like, wow, we're making a lot of API calls that might slow down the response to the client. So this is not something that I would, in the longer term, we would want to have this data locally. We did run into a few problems with this, especially in Europe, that we noticed. And so we are not running this any longer in production. We are exploring other solutions, but we did run it for a while, and it was really cool. But it was more like, this is the lowest hanging fruit, the easiest way to do this that would not require a caching layer or whatnot. And in North America, it's been pretty awesome for us, but you raise good points. And we did not look into those alternatives. And I think in the longer term, we will need to do something like that. So.
Okay.
GeoDjango has a built-in GeoIP.
Oh, well then there we go.
Yeah.
Mr. GeoDjango has spoken, so.
All right, thank you.
Thanks, Mark.
2 questions. The first is, let's say I have a MySQL database, so I can't actually run the GIS functions. So I tried using just as a really rough, this from this degree to this degree, latitude and longitude, and then just finding whatever's in there and just saying, hopefully that's 25 miles. Did you consider a solution, and did it work?
So we considered doing the mathematics, but I wanted something, ideally, our company would get big enough that doing the math ourselves no longer would make sense, so we'd want to offload it to the database layer. So we did not explore that. There is some MySQL support, so it's not awesome, but there is a little bit, and so you're not totally out of luck. But I think for really small instances, doing the mathematics is totally fine, and you can get by. You can even get by with SQLite, I think, in some cases, but I'm not exactly a MySQL expert. So.
How about, so what I was doing is more just instead of a 25 radius, I did a
doing a
box.
rectangle?
Yeah, a rectangle. Without, is there any limitations to that solution?
I mean, not, unless you're doing, so you were treating the Earth as being flat?
Well, yeah, in that case.
Okay, because that was something we honestly considered, because for short distances, it's not that big of a deal if you treat the Earth as flat. So you're going to run into problems if people are like, I want to, what is getting everybody, so I actually know, or I did know, I have since forgotten, the accuracy, how much you're losing by treating it as flat, and if you're willing to compromise, and I think it's a 10% difference or something like that in certain areas. If you're willing to accept that, then you're fine, right? And 99% of the time, you're probably fine. We're not doing driving directions, right? We're just showing vendors in a general area, and that would probably be cool, but our further product plans would require us to be more concise, and so that's why we didn't want to do that in the beginning. But you could probably get it. I mean, if you're just hacking on something, or if it's not going to be that mission critical, then it's probably fine.
Okay, so my second question is then, I read into the Google API documentation, they say now that the geocoding API, you cannot call it unless you're using it for a mapping purpose. So,
yes, so we ended up, okay, so what this gentleman is talking about, I'm being the horrible speaker and not repeating the questions, I apologize. So there are in terms of service, like any API, you should read the terms of service. And the terms of service say that you need to display the results from the Google Geocoder in a map. And so for our solution, we do display them in a map because a map does make sense, and you can pop in a nice little map. But if you are using it and not displaying the results in a map, you are violating the terms of service. As to what will happen to you, I have no idea. There are a few alternatives that I've read on Stack Overflow that eventually we might go to if we want to use this service and not use the map, but very good point.
All right, thank you.
Thank you.
Hey, I don't really have a question, but maybe like an addition. I know you mentioned getting rate limited, and I have felt that pain as well. And recently I had a need to geocode like 3 million healthcare providers. Wow. And I stumbled across this thing called the Data Science Toolkit. I don't know if that would be of use for you, but it seems to have a Google compliant geocoder, and they have like an AMI and I think a Vagrant VM that you can just download and fire up. And so I've used that successfully internally. So that would be a good thing to add there. So enjoy the talk.
I appreciate it. Thank you.
Sorry. It's called the Data Science Toolkit. I think datasciencetoolkit.org or something like that. It's got a whole bunch of APIs that kind of come pre-built in this little VM, but the one I used was the geocoder because I got rate limited. So there you go.
And
like, because I didn't know anybody else doing it.
Oh, 1, 2, 1, 2, 1, 2, 1, 2. You hear me? 1, 2, 3, 1, 2, 3. Awesome.
Good afternoon. Our next talk is by Raji Burnman, and it's going to be on real-time tracking and mapping of Geographic objects?
Geographic objects.
Geographic objects.
Yeah.